This video will show some examples of how to find the domain of root or radical functions. Here we have a function that has an even index. It's a square root function, and the expression under the radical is a linear function, 10 minus 5x. Since we want to make sure what's under the radical sign only evaluates to a positive or non-negative number, we want to set up the inequality 10 minus 5x is greater than or equal to 0. This is a linear inequality, and we can easily solve it, and we see that only values of x that are less than or equal to 2 make 10 minus 5x greater than or equal to 0. Therefore, the domain is all real numbers less than or equal to 2. Here's the graph of this function. Now, in general, when we have an even index radical, so n here's an even number, we have to make sure that the expression g of x under the radical sign is going to evaluate to a non-negative number. So we're always setting up an inequality. The inequality g of x is greater than or equal to 0 when n is even. But how we do this, how we solve this inequality, depends on the type of expression that g of x is. So we just saw a linear expression. We solved a linear inequality, and that's straightforward. We'll see later on in the class, when g of x is a polynomial function, how to solve a polynomial inequality. Now let's look at an example where the expression is under an odd index radical. So here I have another linear expression under a cube root function. Since the cube root can take positive and negative values, and I know that the domain of 10 minus 5x is all real numbers, I know the domain of my cube root function is also all real numbers. Here's a graph of that cube root function. So now let's look at another example. So we have a cube root of a function that's certainly not a linear function. Remember, this is a polynomial function. It's a 56th degree polynomial, but it's still just a polynomial function. So since a polynomial has a domain of all real numbers, this means that I can put anything in this expression, g of x, and I can get a positive or negative value out of that, and that's fine because I have an odd index radical. So it doesn't matter how large the exponents are, the polynomial always has a domain of minus infinity to infinity. Therefore, the domain of this radical function, since the index is odd, is minus infinity to infinity. And here's the graph of that radical function.